Hello viewers! You've probably already seen my video about the AI agent working in SAP. Today, I want to show you the progress I've made. I equipped the agent with some additional tools. It can now handle multiple windows and more advanced user interface elements. By handling more elements, the agent now uses screenshots less often. This makes the agent faster and consumes fewer tokens, which translates to lower costs. But enough talk. Let's dive into the presentation. Today, we're exploring everything related to ABAP. It might not turn our agent into a full-fledged SAP programmer yet, but it could at least become a developer's little helper. Alright then, I'll start by asking the agent something simple. Let's see if it can find some basic information about one of the really old data types. It opens SE11, switch radio button and enter the data type name. Dictionary is displayed, but the agent switches to version information. The details I requested are on the screen. Now it takes print screen. Everything happens in real time, so you have to admit that the agent is quite efficient and fast. We already have the result. Yes, this object dates back to the last millennium, over a quarter of a century since its last update. Let's move on to something slightly different, but still potentially useful for a developer. I'll ask about the access control list for program registration, which is an important part of an interface build. Specifically, whether it's possible to register a program named Power. The SAP AI Agent goes to Gateway Monitor, then from menu selects Expert Functions and ACL files. We don't see this because this is in the background. RigInfo is the second tab. To answer the question, the agent takes a screenshot. This is still sometimes necessary, but in many cases it can manage without looking at the screen. The answer is, of course, correct. It even specifies which line of the ACL file allows it. Let's focus on something a bit closer to programming. To start, I'd like to show you my program, which I already presented in the previous episode. It's a simple report for dividing two numbers. However, it has an intentional flaw. Instead of protecting against division by 0, it prevents division by 7. I'm asking the AI agent to review it. It goes to ABAP editor, then enters the report name and displays it. The bug is related to the first if clause. Look how fast that was. This time the agent didn't need a screenshot, so it was lightning quick. The agent rightly points out that preventing division by 7 is highly unusual. You should know that this report lacks protection against division by 0. If someone enters 0 as the divisor, a runtime error is generated. I'll use this fact in the next example. Remember, I'm starting a new session, so the agent has no knowledge of the previous conversation or this program. Without providing any details, I'll ask it to check dumps and fix the issue. The AI agent goes to ST22. It views today's dumps. Double-clicks on the first one. The next logical move would be ABAP editor button. Yes, exactly. Edit mode has been enabled. Now I expect replacing the code with a new version. Yes, 7 was replaced with 0. Program has been activated successfully. Perfect. You might say it's just a fairly obvious bug in some basic code. Any junior developer could quickly fix it. On the other hand, detecting the bug, analyzing the program, and implementing a fix in less than 30 seconds, that's impressive when you look at it that way. It's also worth noting that thanks to recent updates to the agent, not only is code editing now possible, but there was no need to take any screenshots throughout this task. This is one of the reasons why the new version of the AI agent performs faster than the previous one. Let's also take a look at the analysis provided by the SAP agent. It identified the division by 0 error in my program, implemented a protective fix, and activated the new version. It even provides the full updated version of the code. This is the kind of information you'd expect from a person if you assigned them this simple fix. Let's now perform another experiment with the same program. In international organizations, an important aspect of developing software is translating it into different languages. While my program isn't exactly technically prepared for this, I'll ask the AI agent to prepare a translation of my report. It goes again to the code editor. This is a good choice. In fact, editing the code is not needed, but it's fine as you can find an option for translation also here. Yes, this is the option. As you can see, only title can be edited in the translation tool as the rest is hard-coded. I believe that this is correct translation as LLMs are good in this area. The translation proposal has been saved. Obviously, this isn't the end of the process, but at least the SAP agent chose the right approach to tackle the task. Naturally, a senior developer would probably modify the program further and introduce more text elements suitable for translation into multiple languages, but I consider this a good start. As you can see, the agent is still working in the background. The final query is probably taking longer. After all, the amount of data is growing, and I'm using OpenAI's remote API. However, this isn't really a big issue. That took a moment, but the agent has finished its task and returned a summary. Now let's move on to something else. A developer sometimes needs to use a command at the operating system level. These are usually defined by a basis administrator, but there's nothing stopping us from asking the AI agent to handle it. I'll ask it to create a command referencing a non-existent script and check if everything works correctly. The SM69 transaction is used for defining external commands. The option to create a new command here is entirely appropriate. The command was defined correctly. Now it's time to execute. As expected, the non-existent command couldn't be executed. Of course, the agent doesn't know that the command doesn't exist, but its final analysis is very accurate. The initial suspicion points to a missing script or an incorrect path, but it also suggests other possibilities to check. In my opinion, it's very on point. Take note of the errors that appeared in the agent's window. This happens sometimes because the agent isn't perfect yet, and doesn't know all the elements of the user interface. However, it often manages to adapt to the situation and complete the task correctly. Let's finish by looking at something a bit more challenging. Or maybe not so much. I'll request a report that lists users along with their account creation dates. A classic task, one we've tackled before, but this time I won't have to paste the code into SAP myself. The AI agent will handle it from start to finish. The well-known code editor. I'm curious what program name the agent will choose. Nothing's happening. Strange. The agent is taking a screenshot as if it got lost right at the beginning of its process. Interesting. But at least it chose a logical program name that adheres to SAP naming conventions. Notice that the agent can now handle the successive pop-up windows, or at least I hope so. Yes, it's going quite well so far. The agent selected the correct options. Here, it would be logical to choose local object. Notice that the agent is making some decisions on its own. And we have an empty report. Now the SAP agent needs to prepare the program code according to the specification. I believe it can handle it. And there you go. A select statement from the USR02 table, fetching bname and erdat, the minimal dataset I requested. The program has been successfully activated. Now it's time to run it to prove that it works correctly. Surprisingly, this isn't always the case, and the execution might end in an error. But here we go. A list of users in my system, complete with the creation date for each account. Perfect. Of course, this is a very basic program, and AI has created better ones for me before. But what's important here is that it can save it in the system and test it on its own. Compared to the previous version, it can do much more within the system. All it took was giving it a few additional tools. By the way, if you're interested in how programming skills in ABAP have developed across different major language models, I recommend checking out the series of videos on this channel. In the past, we've tested the programming abilities of various language models. And finally, a few words of clarification. None of the queries sent to the agent were manipulated. Everything happened in real time, which is why some tasks took longer. However, the AI agent is still not capable of doing everything in the system. It's improving, especially as it gets more tools. Keep in mind, though, that not every execution is successful. It sometimes stumbles spectacularly. I'll probably showcase a full summary of its capabilities in the future if there's interest. If you enjoy my project and think it's worth sharing, feel free to spread the word among your friends. You can also give it a like and leave a comment. It's always appreciated. That's all for today. May your AI agents never abuse their privileges. See you next time.